In this video we are going to talk about the components of a vector. So what we have? We have a vector A and we want to know what is the component of a vector. The vector A always can be written like A, the vector A, some quantity on the x-axis in the I direction plus some quantity AY in the J direction and AX. So what are the relations? This is the vector A, and clearly AX is the magnitude of A by cosine of theta. But you have to be very, very careful with this theta. This theta is measured from the x-axis, and this theta is taken as positive if you go counterclockwise. So for example, this theta will be negative theta, probably minus 45 degrees. So if you are going to use this equation, you can have, you need to put the angle measured from the x-axis and counterclockwise the angle like this one is a positive angle. Like this angle is negative angle. So AX is magnitude of A by cosine of theta. Very clear, cosine of theta is this quantity divided by this magnitude of A. So AX is magnitude of A by cosine of theta. I have done many times in different videos. While AY, this length, if you make the sine of this angle, the sine of this angle is AY divided by the magnitude of A. So AY is magnitude of A by sine of theta. Very clear. The tangent of theta is AY divided by AX. The tangent of theta is this divided by this. So you can use always these equations to calculate the components of a vector, but you must be very, very careful. Always theta must be the angle from the x-axis and have to be taken as positive or negative depending if the angle is counterclockwise or clockwise. Okay, so two examples will be clarify this idea. Let's go to make one example. Suppose this problem, they say we have a vector A, which magnitude A is 5 meters. Let's say it's a displacement vector, and the angle that makes with the x-axis is plus 30 degrees. What is AX? Very easy. AX is the magnitude of A, 5, by cosine of 30. What is AY? AY is 5 sine of 30. What is the vector A? The vector A is AXI plus AYJ, meaning that the vector A is simple 5 cosine of 30 in the I direction plus 5 sine of 30 in the J direction. So this is equal to 5 that multiply cosine of 30I plus sine 30J. And this is the vector A. We found the vector A and we found the components. This will be whatever. 5 sine of 30 is 1/2. Sine of 30 is 1/2. So if sine of 30 is 1/2, is because cosine of 30 is, well, I know that cosine square of theta plus sine square of theta is equal 1. So if sine of 30 is 1/2, this is 1/4 plus something equal 1. So this cosine of 30 will be 1 minus 1/4, which is 3/4. So the square root, this is cosine square of theta. So cosine of theta is the square root of 3 divided by 2. So cosine of theta is the square root of 3 divided by 2. So the component AX will be this one. Okay? So I found, I did it. The angle is 30 degrees, is counterclockwise, and I use the correct angle. So let's go to do another problem. So that the problem is like this. You have a vector the vector have magnitude 5, and they give you this angle. If they give you this angle, you cannot make the mistake to make AX equal magnitude of A by cosine of this angle, by cosine of 60, or an AY magnitude of A by sine of 60. No, this is wrong. You have to take this angle, 30. So when you take this angle, the problem is converted in the same one. In the same one that we saw. So let's go to see another example. Let's say that the vector is this one, magnitude 5, and the angle, let's say, 45 degrees. What is AX and what is AY? This is the question. And what is the vector A? Well, the vector A is something in this direction that is positive plus something in this direction that is negative, and the sum of these two quantities will be the vector A. So I want to find the vector A. So what is the component of AX? It's magnitude of A, I know, 5, by cosine of 45? No, cosine of minus 45. But cosine of minus 45 is the same than cosine of 45. We are lucky. So this quantity will be positive. So AX will be 5 by cosine of 45. Cosine of 45, sine square of x plus cosine square of x is equal 1. So I know that when it's 45, the sine and the cosine are equal. So 2 times sine square of x will be 1. So sine square of x will be 1/2. So sine of x will be 1 over the square root of 2. So sine of 45 is 1 over the square root of 2 plus nothing. And AY will be 5 by sine of what? Of 45 or minus 45? Minus 45, of course, I have told you. But the sine of minus 45 is minus 5 minus a square root of minus 1 over a square root of 2. So what is the vector A? The vector A have AX 5 cosine of 45 in the I direction. This is positive, plus AY. But AY is minus 5 over a square root of 2 in the J direction. So this vector A is this vector. You catch it? I hope so. Now let's go to see another that is more peculiar and we will use a lot. Is the component of a vector in the case that you have an inclined plane. Let's say this. You have the vector, you have the inclined plane, the angle theta, you have a mass m here. Over the mass there is a force mg, and the force, if you take this x, y, I, and j, the force is going down and have the magnitude mg is going into the j direction with minus sign because it's going down. The force is going down. In any point it's going down. So sometimes we need to work not with this force, with the components of the force in another different system. So we choose another system. We are going to find F prime, the force on the other system, and the other system will be this system, X prime, Y prime. Of course that the force in the prime system is the same force. It's only that we have to find the components of the force in this system O prime, Y prime, X prime, Y prime. So the component will be, this force will be made on the system X prime, Y prime of this force going down and this force going in the in this direction. I can put the vector I prime in this direction, I prime, and j prime on this direction, j prime. You see the two vectors, you see the O, the system O, you see the system O prime. So let's go to convert this force into the force F prime in the new reference. So in the new reference, F prime will have a component, these components. So let's go to find the angle. This angle theta is the angle that makes this line with this line. But this line is perpendicular to this line. And this line is perpendicular to this line. So the angle theta is here. Is here. I repeat again here. I repeat again. This is the angle theta, okay? This is the force is going down. This is the new system, x prime, y prime. So I say that this angle is the same as this angle. So let's go to C. And this angle, of course, is the same as this angle. So this line is perpendicular to this line, okay? And this line is the angle that makes this one with this one, this angle. So the perpendicular to this line is this line. So two perpendicular lines makes the same angle that is here. I repeat again, this is the angle made by this line and this line. I choose a perpendicular line to this one, is this one. I choose a perpendicular line to this one, is this one, and the angle inside is the same as this one. So this is a property of the geometry that if you find two lines that have an angle, the two perpendicular lines have the same angle. But this angle is the same as this angle. So I now have to express the force in terms of the new component of the system. So this force will be this one plus this one. So will be, I call this, let's say that I call y prime like this. No, I don't like to put, I like y prime like this. Y prime like this and j prime like this. So the force S prime will be some quantity in the j prime direction. So this is the magnitude of F. This is the magnitude of F, everything. What will be this quantity? This quantity is the quantity that is on the j prime axis, and the magnitude will be magnitude of F by cosine of theta. So magnitude of F by cosine of theta in the j prime direction minus sine. This is the force. And the other component of the force will be, this is the magnitude of the force. I have to project this force to take this side of the component of the force. So this force is made of two forces, this one plus this one. You see, this one plus this one is this one. So what is this one? This one is the magnitude of F by sine of theta. So I put it here, plus the magnitude of F by sine of theta. And if I have choose I prime in this direction, so there should be minus also. So F prime will be, magnitude of F is mg cosine of theta in the j prime direction. So this is mg cosine of theta, and this quantity is mg sine of theta. So the vector F prime, that is the representation of the force in the system y prime, x prime, y prime, will be minus f cosine of theta g prime, correct? And if I take y prime minus f sine of theta I prime, this is the force. And of course, if the magnitude of f is the weight, the force will be mg minus mg cosine of theta j prime plus sine of theta I prime. Well, this is the representation of the force. But what you have to understand is these things. Very easy again. So I repeat again. This is the mass m. This is the force F. In these new systems, the component of the force is this one. This angle is theta. I prove you that this angle is also theta. So the component of the force F have a magnitude. The magnitude of F in this case is mg. And this is mg cosine of theta. And this part is mg sine of theta. You have to think about this once and again until you catch it. It's not so easy, but at the end you will realize that it's very, very easy. So this is the magnitude of the force. The component of the force in this direction is this one and this one. So let me write this one, okay, plus this vector, make this vector the force. So this vector have a magnitude, this one have a magnitude, and the magnitude that it has this vector is mg cosine of theta. And the magnitude that has this vector that goes in this way, like this, coming to my arrow, this vector have the magnitude mg sine of theta. So there are two forces. There are one force F that is decomposing to two forces. One around this axis and the other one around this other axis. So we change the axis to visualize the force F and to visualize the forces over the two axes, this axis and this axis. So we will use this thing many, many, many times. So in problems that in Newton problem you will use many, many times. So make 130, 132, 133, 134, 135. 1, 2, 3, 4, 5 problems. Good luck, good luck.